So today we're going to talk about parallel and perpendicular lines. We have a guest too. Hey, come here. Yeah, this is my cat, Bellatrix. With that, I'm going to disappear us as we show you guys some stuff. Okay, so parallel and perpendicular lines. So we have two special instances of the relationship between two lines. One is parallel. Sometimes you'll see this shorthand is just written as two parallel lines. Two parallel lines are lines that have the same slope. So if you were to graph them, you would have two lines that run side by side like train tracks forever and ever and ever. And what will happen if you have two parallel lines is that they will never ever intersect. So they do not intersect. We also have perpendicular lines. Perpendicular lines. This is sometimes denoted with this little upside down T looking thing because that's exactly what happens with these lines. With two perpendicular lines, the lines will cross each other and they'll cross each other at a right angle. So when they cross, there's a right angle in that corner where they cross. So these cross at a right angle. My cat is biting me. She is crazy. All right, so perpendicular lines do intersect. They intersect at one point. The thing that really matters the most for us in Chapter 8, not necessarily Chapter 9. In Chapter 9, the whole intersect versus intersect at one point. This is the most important. Intersect at one point. This is the stuff that's important for Chapter 9, where we're moving next. For the chapter that we're in, the thing we care about most is basically the relationship between these slopes. So in this case, the slopes being the same for parallel lines, and for perpendicular lines, in order to cross at this 90-degree angles, the two slopes are opposite reciprocals of one another. So slopes, this is a pain in the ass to write, are opposite reciprocals. So what does that mean? In the case of perpendicular lines, this would mean if our first line looks like this, 2x plus 4, our perpendicular line would have to have a slope that is, one, the reciprocal of 2 over 1, which is 1/2, but also the opposite reciprocal. We need a negative 1/2 x. And then it doesn't really matter what the b portion is. So this is the relationship. These two lines would be perpendicular versus two parallel lines would look like y is equal to 1/2 x plus 3 and y is equal to 1/2 x minus 5. Those two lines would be perpendicular to each other versus the opposite reciprocal. So what the heck do we need to do with these in our algebra class in Math 92? Well, first off, we need to know those relationships because I could definitely ask you questions about them. But more importantly is that I can ask you more about those equations for lines inside of this perpendicular parallel thing. So here's an example. Find the equation for the line parallel to y is equal to 2/3 x plus 5 passing through, and I just make up any point I want, let's say 7, 6. Now this is another find the equation for a line question, just like the ones in the video for 8.5. If we don't have the slope and all we have is a point, but the fact that we've been told that our line is parallel to another line means that we do have the slope. So your first step, just like in those hardest questions for finding an equation, is to figure out what your slope is. In this case, since they're parallel, the slope is going to be the same. So you've already demonstrated one bit of knowledge. Okay, parallel means they're the same slope. So you've already got some points on this question. And then, well, if we know that, we know y is equal to 2/3 x plus b, and the only thing we're missing is this b. So now we do our same normal second step, which is to figure out what our y-intercept is. So we'll figure out what b is, and in that case we're going to use this x and y that were given to us to try to figure out b. So we know 6 is equal to 2 over 3 times 7 plus b. And remember, we can make this 7 over 1, and then we'd have to solve this out. Now remember, this is plus. We're not going to multiply by a reciprocal because this is not multiplied to our b, it's plus our b. So instead we are just going to subtract it to get rid of that term and move it to the other side. So we end up with whatever the heck 6 minus 14 thirds is, which is 4 thirds. So 4 thirds is equal to b. I'm not lying. I don't think. Yes. All right. So, and after that, you're done, right? We'll just write this out. Y is equal to 2 thirds x plus our 4 thirds that we found. Box it up. If we wanted to check this, we would check by just plugging in our point. That if we had 6 is equal to 2 thirds times 7 plus 4 thirds, we get that 14 over 3 plus 4 over 3 is equal to 18 over 3, and that equals 6. So we feel good. And it is parallel because, again, these two lines have the same slope. So I'm going to give you one of these to try. So here's the one for you guys. Let's do, I'm going to give you guys the harder one, obviously. Find the equation for the line. Perpendicular, so you guys have the opposite one, perpendicular to y is equal to, let's say, 2/5 x minus 7, passing through the point, let's do, I don't know, 4 comma negative 3. Alright, so take a second, pause the video, see if you could solve this question. It's harder, but I think you guys can do it. So hopefully you tried that on your own. Again, we're finding an equation, so we know our goal is to get something in y is equal to mx plus b in our slope-intercept form. And again, first step is going to be to figure out our m. In this case, we are told that our line is perpendicular to this one, which means that the slope is going to be the opposite reciprocal. So the slope of our line, we're going to make this the reciprocal, flip it upside down, and then make it negative since our slope was originally positive. So this is our new slope of our line, or our slope of our line that is perpendicular to that one. Next thing you do is go ahead, find your b, which is just plugging and chugging. So we know y is equal to negative 5/2 x plus b, and we happen to know a particular x and a particular y. So negative 3 is equal to negative 5/2 times 4 plus our b. We clean this up a little. We got negative 3 is equal to negative 10 plus b. And then all we need to do is add 10 to both sides. And we have that b is equal to 7, and we are now officially, as soon as we write out this equation, done. Let's go ahead and actually graph these two just to visually see that 90-degree angle, because we haven't really seen that yet. It might just be a nice finish for this one. If you don't want to see it, you don't need to keep watching. But let's do it. So our two equations, the original was y is equal to, I had to scroll back up, 2 over 5 x minus 7. Was it minus? Yeah. And then our new one was y is equal to negative 5/2 x plus 7. So we're going to go ahead and graph both of these, which means I'm going to bust out my terrible, terrible handmade graphs that are not at all to any sort of good scale. But we'll do it. Okay, so let's go ahead and first we'll graph in red our top equation. So we're going to start at negative 7 for our y-intercept, and then we are going to go ahead and rise 2, run 5. So rise 2, run 5. So there's our next point. We could rise 2 again, run 5. Assume those things are nice and evenly spread out. Rise 2, run 5. And then connect them all with the straightest line we can manage. And let's go ahead and do the other equation in green. So we'll start at a 7, positive 7 for our y-intercept. So we're there. And then we're going to rise, or in this case, fall 5. So we got a negative 5 at the top, so we'll go 1, 2, 3, 4, 5, and run 2. Rise negative 5, run 2, negative 5, over 2, so forth, so on, till eventually we have a nice, pretty line. That is terrible. Assume it went through those points. But what's going to happen, because of these opposite reciprocal slopes, is where these meet, it's going to be a 90-degree angle. This will always happen with those opposite reciprocal slopes. That's what we're aiming for. So a nice graph sort of convinces us, sure enough, that we have graphed a good line that is perpendicular to original, and it does indeed pass through 4, negative 3, because that would have been this point right here. So check marks on both things we were trying to accomplish here. So that's it. That's parallel and perpendicular lines. There's really nothing else to say about them.